My name's Aaron, and I'm the last lecturer on PCL. This is looking primarily at lasers, selective laser sintered PCL, and that's a picture of the powder before the process. So one issue they ran into is it's not very uniform. You have some small pieces and some very large pieces, and they actually sifted the powder to try and get a more consistent particle size. So the title of the paper was In Vitro Cell Biological Performance and Structural Characterization of Selective Laser Sintered and Plasma Surface Functionalized Polycaprolactone Scaffolds for Bone Regeneration. So basically they just used this scaffold geometry here. It's a 12 millimeter cube. And they did surface treatments after the SLS process to improve hydrophilicity and cell behavior in vitro. So they were asking, okay, how do two surface treatments affect these properties, and both mechanically and in vitro? So they used PCL scaffolds. The two surface treatments, the first was an oxygen plasma surface treatment, and the second was a gelatin B fibronectin surface treatment, which is just a protein coating. And then the tests, they did a water drop test for a qualitative measure of hydrophilicity, and a 2D optical microscopy for pore morphology, a 3D micro-computed tomography for surface roughness. They did compression testing with an adapted instron machine, and then they did in vitro studies with osteogenic and growth medium for cell proliferation and differentiation. So for the first part of the study, they were talking about out of the in vitro, so there's no growth solution. They're looking at surface treatment behavior on pore size, roughness, and strength. They didn't see any major shifts to those properties. So for the compression stiffness, the PCL02 treatment and the gel B treatment, they were all within the same range. And then the surface roughness is on the left, and those three columns are just different measurements, not different materials. So they're all relatively close to each other. However, they did increase the hydrophilicity of the PCL, which is naturally hydrophobic, and that's what this picture is showing. So for cell proliferation and in the body, you want the material to actually be hydrophilic, and in order to get PCL to be hydrophilic, they use these surface treatments. And the second part of the study was how does it behave in vitro. One of the biggest points they found was that the oxygen plasma showed a negative influence on proliferation and differentiation, while the double protein coating showed a significant increase in differentiation. So they didn't really give much of a hypothesis as to why that was. But after 14 days, you can see the gel B is on the right here, and it shows a significant increase at the end of the trial. So in summary, the oxygen and gelatin B surface treatments, they did increase hydrophilicity without significantly affecting the pore morphology or the roughness or mechanical strength. Oxygen was not good for in vitro performance. It negatively affected the cell behavior, while the gelatin B did increase cell behavior. And then a personal critique, I thought it was pretty useful, especially for upcoming bone repair and whatnot. You can combine this with Eric's study and even Luke's for scaffolds, different scaffolds and whatnot. And but it's a good reminder that you can do post-processing on additive manufactured structures as well as metal structures and whatnot.